Hello everyone! In this lesson, we will be discussing inverse trigonometric functions. Our objectives are to determine the domain restrictions for trigonometric functions, to figure out the domain and the range of inverse trigonometric functions, to graph inverse trigonometric functions, and to state the meaning of and evaluate expressions involving inverse trigonometric functions. The first inverse trigonometric function we will be discussing is the inverse sine function. First of all, consider the original sine function. Consider the original sine function. What does it look like? The original sine function is periodic, is a periodic function. That means it repeats in intervals. The period is 2 pi. It oscillates in the range of -1 to +1, and it snakes through the origin 0, 0, increasing, and it's increasing up through the origin. We can call that y is equal to sine of x. Now, if we observe something about this function is not a one-to-one function. We need a function to be one-to-one so that we can make an inverse function from it. So we need an invertible function. So we have to consider ways that we can make y is equal to sine of x invertible. One way that we can do this is to sort of restrict the domain in areas that will make it one-to-one. So we have to find some nice places that we can make a cut on the domain so that within that restricted area, the sine function is one-to-one. So we can think of an area like pi over 2 to 3 pi over 2. Notice here, each x has 1 y and each y has 1 x. So it is one-to-one. Also, between -pi over 2 to pi over 2, all of those are one-to-one. Also, between -3 pi over 2 and pi over 2, the function, this restricted area of the sine function is one-to-one. Now let us consider which would be the best area to restrict the sine function. We choose the region -pi over 2 to pi over 2 of the domain of the sine function. Why? Because it is a nice little area that has your 0, 0, your origin as the midpoint of it. Your sine function snakes through the origin right there. When we talk about inverse functions, we were graphically looking at them in relation to the line y equals x. So it would be nice to, just sketch the line y equals x right in that area and then reflect that part over the line y equals x. So graphically, it is a nicer area to choose. And we will see some other reasons when we look at the unit circle as well. But for now, let us choose the region from -pi over 2 to pi over 2 of the graph y equals sine of x as our restricted sine function. As a matter of fact, over the years, that is what everyone has chosen. The original sine function, as we said, was not one-to-one. We restricted it in order to make it invertible, and we choose the restricted region of the domain on the interval -pi over 2 to pi over 2. Now, this restricted function has domain -pi over 2 to pi over 2 inclusive, right? So what that means is that our inputs would be angles. What is our range for the restricted sine function? The restricted sine function has a range -1 to +1 inclusive. And your output there are trig ratios. Now, how do we find the inverse sine function from this information, or the domain and range of the inverse sine function. The domain and range of the inverse sine function can be had by interchanging the domain and range of the restricted sine function. So the inverse sine function based on the restricted sine function will have domain -1 to 1 inclusive, where your inputs here are your trig ratios, and your range -pi/2 to pi/2, which are your outputs, and your outputs are angles. Now, what would a graph of the inverse sine function look like? Remember that we said, graphically, if we just reflect your original restricted sine function through the line y is equal to x, then that would give us our sine inverse of x function. So this red graph right here would be what it would look like. So we interchange the domain and range and the ends. If we have some graphing software like Desmos.com, would end up or set that graph, it would look like this. So the graph of y is equal to sine inverse of x. In notation, y is equal to sine raised to the -1 of x, or we can say y is equal to arc sine of x. Now, I want to caution you here about notation. Be very careful when we're looking at sine raised to the -1x as our representation for sine inverse of x, because in general, when we have something raised to the -1, we normally tend to write that as 1 over whatever that thing was. However, in this situation, sine inverse of x, written sine raised to the -1 of x, is not equal to 1 over sine of x. Recall that previously we had met 1 over sine of x, and we had named that as cosecant of x. We're going to keep that same meaning here. Sine inverse of x, written sine raised to the -1 of x, therefore will just be a notation for just a sine inverse of x, nothing more. Let's talk about the meaning of sine inverse of x. Sine inverse of x here means the angle y whose sine is x in this restricted interval, -pi/2 to pi/2 inclusive. Therefore, it will return only one value because of this restriction. Only one angle. Okay? Only one angle will be returned. If we think of the unit circle in this situation, notice here, -pi/2 to pi/2 will be in quadrants 4 and quadrant 1. Arc sine of x will live right here. Arc sine of the angle will live right here in this labeled region, quadrant 1 and quadrant 4. However, whereas in quadrant 4, we also had positive angles, like from 3pi/2 to 2 pi. Here, when we're talking about inverse sine or sine inverse, we'll only be referring to angles -pi/2 to 0. So the angles here in the quadrant 4 will all be negative. Okay, so we use the negative values instead of the high positive values. In terms of equivalences, y is equal to sine inverse of x is equivalent to sine of y equals x, right? Let's look at a more specific example. State the meaning of and evaluate y is equal to sine inverse of 1/2, or arc sine of 1/2. What does that mean? The meaning is the angle y whose sine is 1/2 in the interval -pi/2 to pi/2 inclusive. Which angle is that? We know the sine of pi/6 is equal to 1/2 in the interval -pi/2 to pi/2. Therefore, the angle y, the special angle y that we are looking for, the specific angle y that we're looking for is y is equal to pi/6 radians. Thank you so very much, and see you next lesson.